Hi, in this video, I'm going to demonstrate how to implement both a stack and a queue using a linked list, and also I'm going to walk through the time complexity of each of these operations. Looking at the stack, it follows the principle of LIFO, which is a last in, first out principle. And the internal structure, I would use a singly linked list. I will keep a reference to the head of the list, and also the top of the stack will be the head node. So I'm going to do that. Then looking at the operation, I'm going to perform the push, the pop, and also the get top, and also the is empty. Looking at the push, which is add to the stack. To add to the stack, add a new node at the head of the stack. This is a constant time operation because it doesn't require a transversal. It's a constant time operation and is a O1 complexity. Then looking at the pop, which is removing from stack from the head. I'm going to remove from the head. Remove the node at the head. Just update the head of the next pointer, or update the pointer to the next node of that linked list, and the time complexity is going to be an O1 complexity. Then going to get top, which is the peak, simply return the value at the head node. If you return the value and the time complexity is also O1, then I'm going to look at its empty, check if the head node is null or none, and the time complexity is also O1. So using the head of a singly linked list, not a doubly linked list, a singly linked list at the top of the stack ensures all operation, the push, the pull, the pop, and the rest things. Then I'm going to move over to the queue. Looking at the queue follows the FIFO, which is the first in and the first out principle. I would also do what we call the NQ and also the DQ. Looking at the operation, I will use a singly linked list. Looking at the NQ, create a new node and attach it to the rear or to the next, or then move the rear pointer to the new node, and also the time complexity is O1. Looking at the DQ, or remove from front, remove the node at the front, move the front pointer to the next node, and the time complexity for this action is going to be linear, which is O1 time complexity. So we can either maintain a separate counter variable of O1 or of an ON, but in general the total time complexity is a linear complexity, which is O1 complexity. Thank you.